This tutorial is to help you better understand formulas and equations. A chemical formula represents a compound. One very common example is H2O represents water. In this formula, there are several components. There are the symbols. These come from the periodic table. They represent the elements. And we have a subscript. A subscript is a number that tells me how many of this particular element is present in the compound. So in this particular example, we have 2 hydrogens bonded to 1 oxygen. You'll notice that there's no subscript next to the O. That always means there's simply 1. Let's look at another example. H2SO4. In this compound, this subscript tells me I have 2 hydrogens. The blank here tells me I have 1 sulfur, and then the 4 here tells me I have 4 oxygens. Now, if we include a coefficient in front of a formula, it gives us even more information. If I put 2 in front of our NaCl, or sodium chloride formula, this tells me I have 2 molecules of sodium chloride. So in this example, our coefficient just gives us a quantity. So if I have 2 molecules of sodium chloride, I have 2 sodiums and 2 chlorines total in the sample. Now let's move on to equations. A chemical equation represents the reaction that makes or breaks these compounds that we've talked about. We will always have reactants on the left as far as our class is concerned, our products on the right. The arrow here represents the word yields or produces. It means that these reactants are going to chemically react and they're going to produce something brand new with its own new properties. 2 examples I have here for you. We've got sodium plus chlorine yields sodium chloride. Another example, 2 H2s and 1 O2 gives us 2 molecules of water. These just show us what happens during a chemical reaction. Now let's talk about the law of conservation of mass or matter. It states that matter cannot be created nor destroyed within a typical chemical or physical change. Every single chemical equation needs to be written in a balanced form to satisfy this law of conservation of mass. Let's do one very simple one. Sodium plus chlorine yields sodium chloride. The way that you can tell that it's balanced is you count how many sodiums you have on the left. We have 1. We have 1 on the right. We have 1 chlorine on the left. We have 1 chlorine on the right. This is balanced. It actually satisfies the law of conservation of mass. Very often you'll find that the equations are written in their unbalanced form. We will learn later how to balance those. Another good example is how water is actually made. On the reactant side of the equation, it says we have 2 H2s, 2 O's, and on the right-hand side of the equation, it says I have 2 water molecules, so that's H2O, H2O. If you go back and count, we can determine we have 4 hydrogens on this side, on the reactant side. We also have 4 hydrogens on the product side. We have 2 oxygens on the reactant side, 2 on the product side, and again, we have a balanced equation. This satisfies the law of conservation of mass.